All right, welcome to Geometry Learning at Home. This is the area of composite figures lesson. This should be the instruction. This is slide 4. On the instruction page, we have slide 4, 6, 9, 11, and 13 that you need to answer to be able to move on through these. So let's go and get started. Which expression can be used to find the area of this composite figure? We see that we have some labels on here already given for us, so we can identify we have all these congruent pieces here, here, here. So all of them can be labeled with X. All right, if I wanted to find the area of this figure, it's two triangles and one rectangle. So the area is going to equal triangle plus rectangle. And I know that the area of each of these is 1/2 base and height. For the triangles, area of a triangle is 1/2 base times height. And area of a rectangle is just base, base times height. All right, so I just need to plug in the bases and heights of the rectangles and triangles. So let's start with this first triangle here. Whoops, let's not do that. Let's call it a number 1. First triangle has a base of x and a height of x. They have to be perpendicular to each other to be bases and height. So the other triangle has the same two pieces, x and x, that we can use. And the rectangle, this side here is x plus x, so 2x. So we could say this side is 2x, the base is 2x, and the height is x. So we get 1/2 x squared plus 1/2 x squared plus 2x squared. Looks like 1/2 x squared plus 1/2 x squared plus 2x squared. We get x squared plus 2x squared is 3x squared. So when you add up a 1/2 x squared plus 1/2 x squared, you get 1 whole x squared. And then when we add 2x squared, we get a total of 3x squared. So it should be the last answer choice on there. For question on slide number 6, we have area of composite figures where we have a shape that we need to break up. Here's the dimensions. What is the area of this proposed deck round to the nearest foot? So we need to break this up into some shapes. I think the easiest one would be if we make a triangle right here. That way we have a triangle, a rectangle, and a semicircle, half of a circle. So we're going to say the area is the triangle plus the rectangle plus 1/2 of a circle. All right, so the formulas we can get from our formula chart. We know the area of a triangle is 1/2 base times height. Area of a rectangle is just base times height. And the area of a circle, we're only going to do half of the circle, is pi r squared. All right, let's go through and see if we can plug in these pieces and simplify, see what we get on this one. So let's start with the triangle. I need a base and a height of the triangle. Well, the base, we could use this piece right here, and then we would need to know the height of the triangle, this piece over here. So the base is 8, and the height, how do we figure that out? Well, if this whole length is 18, and this length is 12 on the opposite side of that rectangle, that means that there's 6 feet left over for the height. So I know 18 minus 12 is 6. The height of that triangle has to be 6. What about the base and height of the rectangle? Well, this one should be pretty easy because we have a base and a perpendicular height on the rectangle of 16 and 18. And the last one is the semicircle. We just need the radius of the semicircle, and we're already doing half of it, so we don't have to do anything special there. So the radius of the semicircle is 8. We can plug that in. From here, you just need to type it in your calculator. You can use a phone calculator, pi symbol should be on your calculator if you turn it sideways, or you can use Desmos Scientific Calculator. So type all of these in your calculator and round to the nearest foot. We get approximately 413 feet squared for area, which should be second choice here. Yep, looks like it. All right, for the next one, question number 9. Area of composite figures on slide 9 says Bonnie wants to make a picture frame. What is the area of the frame if it is 1 inch thick? Okay, so pretty clearly, if you start off with a big rectangle, that you find the area of the entire rectangle, and then if you literally subtract off the little rectangle, you're going to be left with just that. So that's what we're going to do, is big rectangle minus small rectangle for our formula to find the area of this border. So just take the big rectangle minus the small rectangle. Okay, so we know that the formulas that we're going to use for a big rectangle is just base times height of the big rectangle. And for the small rectangle, we're also just going to use a base and a height. So, okay. For the big rectangle, we don't necessarily have the dimensions, so we need to figure them out. It looks like we have the dimensions of the small one, which right here is 5. If we add another inch to that there, and an inch on the other side, we have a total of 7. So the base of that would be 7. And same thing, if we have the height of the small rectangle is 8, we add an inch here and an inch here, we should have 10. So for the small rectangle, we just use the base and height of the small rectangle, 5 and 8. And we don't even need a calculator for this one. 7 times 10 is 70, 5 times 8 is 40, 70 minus 40 equals 30, and I guess it's inches squared. All right, that one was actually pretty easy. Slide 11, looks like we're on. So for this one, hopefully you watched the video explanation. For this one, we're going to find to do this one, to find the area of the shaded region right here, we need to find the area of something called a sector, which is this whole thing right here. And then we're just going to subtract off a triangle from that and be left with the shaded region. So we're going to find the area of a sector and then subtract the triangle. And this actually walks you through it piece by piece. Find the area of the sector, find the area of the triangle. Once you know the area of the triangle, take the sector minus the triangle is the last step that it has on there. Yeah. Okay, so let's go ahead and do that. Area of the sector. So find the whole area of the sector. So area of a sector is basically part of the circle, but it's a fraction of the circle. This conveniently is divided into 4 equal sections. So this is going to be 1/4 of the area of a circle. Another way to do this is in terms of degrees, you could do 90/360th of the area of the circle. In any case, we don't want the whole area of a circle, pi r squared. We only want a fraction of it. And you can either do that by saying it's 1/4, or you could write it as 90 out of 360 degrees. If you had a degree measurement that didn't simplify that easy, you could use the degree measurements. Either way, 90 out of 360 is 1/4. And for the triangle, conveniently, this one, to find the area, it's an isosceles right triangle. So the base and the height are going to be the same because it's a radius of the circle on both of those. So this radius here and this radius here are both going to be 4. So the base is 4. Whoops. And the height is 4 as well. Whoops, that's supposed to be a height right there. Okay, so let's work through this one. Area of the sector with center angle 90, radius of 4 is blank pi, so it looks like we get 1/4 pi 16. 1/4 of 16 is 4 pi, so 4 pi. The triangle in the sector is an isosceles right triangle. That's what we talked about, having 2 congruent sides, so it's isosceles and it's right. The area of that triangle we can find right here. 1/2 of 4 is 2 times order 16 divided by 2 is 8. So then we know 4 pi minus 8 is going to eventually be the area of the sector, which I guess that's the last option on that one. All right, let's see. We got just a couple of minutes here for this one. So determine the area of the archway with the semicircle. So this one can be broken up pretty easily into a couple of rectangles and then a big circle minus a small circle. We're only going to use half of it though. We take the big semicircle minus the semicircle here, and we should be able to get the area of that archway and add it to the 2 rectangles over here. So let's start with the lower supports are rectangles, congruent rectangles, I guess, because they do have the same dimensions. So congruent rectangle. The area of the 2 supports, so 3 times 4, base times height is 12, and 12, so add those together, we get 24. The upper arch can compose a semicircle with a radius of, okay, so if this is 6, this would be 9, so a radius of, oh wait, the whole thing is 6. Let me break that down a little bit better for us. So 3, 3, 3. So then this distance here is going to be 6. And this distance here for the little circle would be 3. Okay. Radius of 6 and the semicircle with a radius of 3 meters. So the area of the archway would be big circle